My name is Rob Whiteley. I'm the Chief Marketing Officer here at NGINX. So I'm going to take you through a little bit of our company intro and the product strategy at a high level. And then what we want to do is start getting into the specific solution areas. So you'll see a combination of demos from people far more capable than I am. So sorry to make you start with a marketing guy, but I was once technical, long ago. So I'll do my best to answer questions. If not, I've got a whole panel of folks that can help me get through it. So first, a little bit of context before we jump in. You'll notice little floppy disks. So one of our claims to claim here at NGINX is that NGINX is so small it could fit on a floppy disk. So we decided to stop saying that and actually prove it. So this is an actual working copy of NGINX open source. So you can run a full website from this disk if you really wanted to. And then just to do a little juxtaposition of old with new, we also have Raspberry Pi 3B pluses, all loaded with Raspbian, also with NGINX open source. And so you can use that to run a website. Maybe you want to make a home file sharing service, do home proxying services. So we really do think it's an exciting time to be able to showcase the power of what we do. We wanted to share all of that with you guys a little bit. For those of you listening in or tuning in, I'm not opposed to sending these out to people that have great ideas. So tweet at us, engage with us. We're always happy to find people who are big fans of NGINX out there. How many of you are familiar with NGINX? Okay, so most either raising hand or nodding. We are most well known as an open source web server. So NGINX started back in 2003-04 timeframe. Igor Sisoyev was the founder. At the time, he was working for a service provider, and he was looking for an alternative to Apache. And so he created a web server in his spare time. And for the first 8 years, he ran it as a passion project. It was a nights and weekends kind of gig. And then around 2011, he actually formed NGINX Inc. I'll get into a little bit more detail. But since forming the company, we've had a great run of it. So just some stats here. There's about 375 million websites. About a third of the known internet actually runs NGINX as the underlying web server. As you go up to faster, higher performing sites, that climbs to about 2/3. So the 10,000 busiest sites or so, 2/3 of those run NGINX. So it's really known as a high performance, lightweight, very portable web server. What's interesting though is ever since NGINX Inc. was formed, the technical thesis behind the company was, okay, no one's ever made any money selling a web server, and I don't think anyone ever will. So what is it you put in front of a web server that is all the infrastructure that makes that website scalable, fast, secure, reliable, doing things like authentication? Okay, let's take that and actually suck that into the web server itself. And so the technical thesis behind the company is more, how do we take all those bumps on the wire that would normally sit in front of the web server and actually make them programmable, capable services that run native on that? And that's really kind of what NGINX is all about. And I think what you'll learn over the next couple of demos is how far we've extended the technology. Yes, we're known as a web server. Yes, we're probably known as a proxy and load balancer. But there's additional capabilities beyond that that we've been kind of hard at work at the last few years. So we have had a lot of success. I won't read all these stats to you. But in terms of the company itself, right, so the company was formed in 2011. In 2013, at the very end, is when we released the first version of NGINX Plus. That's our commercial product based on the open source. We are an open core business model. So there are features in NGINX Plus that are not in open source. It's not just support that differentiates the two. And so a lot of what you'll be hearing from the other speakers as they go into the demo is highlighting capabilities that are actually in that enterprise version of the software, if you will. And we had a great run of it. We ended up raising about a little over 100 million in capital with the last raise from Goldman Sachs. And then this little old company F5 came along and picked us up. And so I'll get into a little bit about that. The acquisition's not closed, so there's only so much detail I can go into at this point. But I'm certainly happy to talk about the vision, why they approached us, and what's been going on from that perspective. And then ultimately, NGINX, just to kind of make sure that it's clear from the get-go, we're going over fully formed to F5. So all the employees, all the offices, the brand, the logo, everything that you know and love about NGINX is going over to F5. There's no desire to sort of break this up or tuck us in as a technology. So I think for those, probably the most common question we get is F5 going to do something to the open source or in some way, shape, or form change the way NGINX open source works? And the answer is, if it's yes, it'll be for the better. They are much more interested in giving us capabilities and resources that little old NGINX couldn't necessarily provide. And so they're very interested in accelerating that, right? It's very, I would argue that we're at a point in time where a commercially owned company acquiring an open source based company is not necessarily the black magic voodoo that it was maybe 10 years ago. I think it is a fairly mainstream occurrence that we're seeing, and a lot of what attracted F5 to the deal was preserving that open source community and some of the technology and the innovation curve you get from the open source side. So again, I'll touch on that a bit more, but I just wanted to kind of mention that.
Apologies if you do cover this, but just a question. Before the acquisition with F5, did you have any partnership or collaboration with them? Are they using NGINX or anything at all within their product or anything at all?
Nope. In fact, to be really candid, our primary sales motion was to replace F5s. So there are plenty of technologies out there that do use NGINX under the hood. Companies you've probably heard, Avi, Kong, others, all those folks use NGINX as part of the product that they've built. That's the blessing and cursing of an open source. You're more than welcome to take our technology and build a business off its back. But F5, no. But we do think, and I'll get into this a little bit more, that the concept of overlap is actually far smaller in the portfolio than you'd think off the bat. Okay, that's a little bit of the corporate backgrounder. Let me instead kind of start off with a little bit more about what are some of the challenges we're solving for customers, and a couple quick examples. We're most known for the folks on the left. Netflix is one of the largest NGINX shops in the world. Every bit of Netflix video flows through NGINX, so anywhere from 1/3 to 2/3 of the internet traffic, depending on time of day. AWS has built ALB around our open source product. And so those aren't customers to us. They're users. They've battle tested the software. They've used it in some of the gnarliest environments in the world. And I think we've gotten a great appreciation for where bleeding edge kind of modern architectures are going. But it is not necessarily our goal to monetize that, because these folks have armies of developers and engineers that they'll throw at tweaking, tuning, and building and modifying NGINX open source. And so that's core to their business. Technology is core to their business. What we're seeing, though, is outside of these pioneers, we're beginning to see a much more mainstream company come on board. They have the same basic mission statement. We need to become digital. So whether you want to use digital transformation or whether you want to just use modernization, they have a top-down mandate to be more competitive in their respective industries, usually because of the folks on the left. But they don't have an appetite to take 10, 12 plus dedicated engineers to babysitting an NGINX real estate. It's not core to their business. They're much more interested in a solution that's more packaged and ready to go for them. So still cutting edge technology, but not necessarily cutting edge operations required to do it. So two good examples to kind of show you the extremes that we operate at. So Capital One, their entire API infrastructure runs NGINX underneath. So it's called DevExchange. They process about 12 billion API calls a day, a peak of about 2 million API calls a second. And so when they were sizing an infrastructure for that, they needed a highly scalable data plane to be able to process all that API traffic. Now this was some 2-3 years ago. We didn't really have a product around API. Later, you'll see the actual product we've built around it, but it was really from the Capital Ones of the world that showed us how to think about API as a specific use case and a specific challenge. And for them, it was all about speed, reliability. They monetize those APIs, so especially as things like open banking start hitting us, there's a world where customers need to open up a credit card, check their scores, check balances. All that capability is API traffic to them. It is the most mission critical traffic they have, and they've done that on top of NGINX. So what was a flexible, lightweight kind of load balancer is now also able to function more as an API gateway, or even as we wrap the control plane around it, full lifecycle API management. So that's one of our most pronounced use cases. What's interesting about Cap One is we were brought in by the DevOps team. So they're a happy load balancer customer. I won't tell you who. You can probably guess. And their goal was not to replace load balancers. They weren't trying to update their infrastructure. They were looking to do a layer on top of that that would handle all this API traffic that was going to be owned and operated and manipulated by the application team. So the DevOps team came in to kind of build that abstraction layer. It's part of their CI/CD framework. It's automated using orchestration tools. It doesn't look, feel, or smell like traditional infrastructure to them. They're just looking at it as closer to the business logic, closer to the applications and the APIs. And so it was core to them to have that kind of lightweight software that sat above the traditional infrastructure layer. Now let me compare and contrast that to AppNexus. So AppNexus is one of the largest ad auction, ad bidding companies in the world. AT&T recently acquired them. And so they're all about performance, right? They need to be able to place an ad auction and then place that ad in 11 milliseconds or less. And so for them, horizontally scaling up hardware just became far too cost prohibitive. They needed a scale out kind of distributed software layer to just simply hit the peak performance requirements they had. So the difference with AppNexus is they are using us as a load balancer. So we load balance all of that traffic coming in and out of their ad network. And we were brought in by the network team. So this was where, unlike Capital One, where they want to put a layer on top of the core plumbing, these folks decided to just rip out the core plumbing and put it all in. So this would be the more traditional software-defined networking if you want to go that route, right? Where they actually have a stated mission to be hardware-free. So they're completely hardware-free at the load balancer stage, and now they're going with routing, switching, all of that, and they're just going through and removing any kind of proprietary, kind of tightly coupled hardware solutions and going all general-purpose hardware running software-based solutions. And that's, for them, not only does it improve the cost and the economics, since serving an ad is very much a cost-driven argument for them, but they've also been able to get aggregate much higher performance. So they've been able to get about 50% more performance at 1/6 the cost of what used to be their traditional hardware load balancers. So I start there because you have cost-conscious, performance-oriented, need-to-go software-based. That's about half our customer base, like AppNexus. And you have application-driven, on the cutting edge of trying to monetize those applications, and it's all about building it into DevOps and CI/CD frameworks, and that's Cap One. So those are probably the two best examples of the types of profiles that we come across. So far, so good? Okay. So stepping back for a second, what are some of the things that these folks have in common? There's kind of two trends that we think kind of go across this, if you will, sort of DevOps and NetOps type world where we tend to have a foot in either camp. The first is that we clearly see companies are trying to shift infrastructure closer to the application. So they're trying to go from, I have one thing that sits at the doorstep of my data center, to I'm actually looking at all the doorways and hallways inside the data center. Each one of those needs to have an intelligent traffic point, a traffic cop that's managing that, whether it's east-west traffic or north-south traffic. And as a result, we see that power is shifting towards applications and DevOps teams. I think if AWS has proved anything to our customers, it's that if you make the infrastructure easy enough to provision and easy enough to manage, the developers will do it themselves. So in a lot of cases, NGINX starts life as a part of the app stack. In fact, 40% of all of our conversations start with the developer, and then 40% of all of our conversations end with an infrastructure person. So we tend to get prototyped into the application as part of that, and then as they go to scale that application and put it in production, we sort of make our way over to the infrastructure side of the house, the network teams, virtualization teams, container teams, where they're looking to say, okay, this now needs to become a blessed part of the stack. We need you guys to own it, scale it, manage it. And so for us, it's clearly a move towards software-defined, kind of scale-out, distributed type architectures. And it's really this concept that instead of one shared infrastructure where all of my hundreds or thousands of apps would flow through it, I actually want to give each app its own infrastructure, at least logically. Actually, it's not, but from a policy perspective, each application can have its own. So in a lot of cases, our customers will actually deploy NGINX instances. Again, fits on a floppy disk. It's about 1.5 megs per app. And so every app could have its own unique traffic policies, protection, security, and we can act as that enforcement point where a lot of other technologies can come in, like WAFs, if you want to have that, or single sign-on and authentication. So that kind of per application, or if you're a SaaS provider, they'll actually go all the way to per tenant. So we'll actually get to the point where some of the larger companies, probably within striking distance of where we sit right now, are actually trying to give it where every customer can have its own unique load balancer so they can have their own traffic management, security, et cetera, et cetera. So that's trend one, infrastructure kind of shifting up to the application as the intelligence moves into software. The downside is developers love tools. And as they gather those tools, it creates a ton of sprawl and complexity. It's not uncommon that there'll be 3 software load balancers, 2 different proxies, a couple different Kubernetes ingress controllers. Functionally, those are all very similar things. They're basically an intelligent point in that network doing some of that traffic inspection, routing. But what happens is it's massive complexity. Giving developers power and choice is an operational nightmare. And so a lot of our companies end up stuck with, okay, we either empower developers, they can prototype the application with whatever they want, but now we're stuck with 2 or 3 of everything. Or we come up with a corporate standard that can't move fast enough and the developers are constantly pissed off and not productive. And so that's sort of the challenge that most companies have. They want to move the infrastructure up, they want to empower the developers, that was the previous trend, but now they're stuck having to mitigate the complexity. All their legacy applications don't go away, the hardware infrastructure is still there. I still love that the cloud is just someone else's data center, right? Hardware still exists, whether you're paying for it or not. And so they're trying to balance that equation. Our thought is that if you make the software easy enough, lightweight enough, flexible enough, you can actually combat that complexity. And if you make it programmable and extensible enough, you can actually get it so that it sits closer to the application and provide the functionality. So rather than coding that logic into the application itself, you can actually make it and expose it as a set of services that the developers can call upon. And that's really where we sit, right? So we see a lot of customers are looking at hard problems around implementing these big prescriptive platform as a service platforms. Maybe they went down the SOA path. They have a lot of legacy hardware. And what we see is that there's nothing wrong with those are all necessary, but they tend to be very inflexible. They have to put something in front of it or around it or as part of it to really handle the traffic, which is far more dynamic. We're big fans of containers in Kubernetes. In fact, I would argue that a big part of NGINX's success has been, it was well timed with the container revolution. But it's not a production ready out of the bat. A lot of companies have to do extra tooling. One of the use cases we'll talk about is the Kubernetes ingress controller. That's a critical component to put in front of your Kubernetes, especially if you're looking to scale or put it in production. So it's not a silver bullet to just think you're going to containers and Kubernetes and call it a day. And similarly, if you think you can just outsource the whole problem to the cloud, then I either have to worry about what happens if I go multi-cloud, and now I have different tools in each cloud with different interfaces, or I have to worry about lock-in. So I think the challenge is to create that lightweight platform, and at the end of the day, that's really what we've built here. So what you're looking at here is what we lovingly refer to as the wedding cake. It's a view of our sort of platform, and what we'll start in the sort of bottom left and go around, right? So NGINX Plus is our kind of core enterprise version. It takes the NGINX open source and adds additional capabilities that allow it to act as a more enterprise-rich load balancer, as an API gateway, as a WAF, or as more advanced caching capabilities. So those are sort of the core use cases that drive NGINX Plus. But NGINX Plus in itself, I mean, if it fits on a floppy disk, it is not going to have a GUI. It's going to be something that's CLI driven, it's API driven. And so we created Controller halfway through last year. So Controller is our central monitoring and management solution. and it's very modular. It's workflow specific. So it has a common set of services around analytics, and you'll see all of this in the demos. But really what you do is you load controller with a module. So if you want to manage NGINX Plus as a load balancer, you would get the application delivery module. And the combination of those two technologies basically makes it an ADC, if you're familiar with the concept of an application delivery controller. That's what ultimately allows us to replace a hardware or load balancer or augment a hardware load balancer. If you want to configure and manage NGINX as an API gateway like Capital One does, then you can load the API management module. And what it's doing is it's adding the additional workflows and capabilities that would make sense for that user, for that audience. So think of it as really just the easy button, right? If you want to roll up your sleeves and go at configuring NGINX to your heart's desire, you can do that. Or we can expose that as an intelligent set of wizards and buttons and widgets inside a controller that make it so that you don't have to know all of the hardcore plumbing that NGINX Plus kind of required up until about last year. Now, we do also have a service mesh strategy. I'm going to end today's session on sort of a preview where we're going there. In full transparency, that's not shipping today. The other two are, so we'll show you demos of those, and we'll kind of preview where we're going with service mesh, if you're familiar with service meshes and some of the announcements that are coming out around, Istio and some of the sort of the next gen Kubernetes networking. And then to kind of complete this diagram is Unit. So NGINX Unit is an open source project. It is not a commercial product yet, and it is an application server. So just like NGINX started life as a web server, we also wanted to come at the application server market. And the first question I always get is, why did the world need yet another application server? And there's kind of two reasons. One is it's a polyglot or multi-language application server. So today it runs 7 languages, all the usuals: Java, JavaScript, Ruby, Perl, Python, Go. And so the goal with Unit is not necessarily to be an app server. It's to create an API-driven dynamic capability so that you can almost think of it as do-it-yourself or on-prem serverless. You should be able to just give it your code and it runs it. And so we think there's some really fascinating things that we can do to the application server market, just like we did to the web server market, right? There's a bunch of things you stick in front of your app server to make it secure, to make it reliable, to make it part of the enterprise service bus and all the things that need to get connected to it. So we think there's a long-term opportunity for us to actually begin building that directly into the app server itself. I'll give you a service mesh example. This is forward-looking. This is not available today, but if you're building a service mesh, then you have to give each microservice its own sidecar proxy. Well, what if the proxy was built into the actual app server itself? So we could create a proxyless server mesh because that's intelligence that's built into that. So the same thing that's executing the code is able to do the intelligent networking in and out of that point, right? And again, just like NGINX core, Unit is very small, very lightweight. In fact, it was written by Igor, same guy who wrote the original NGINX. And so it's ultimately a foothold in the future for us. It's where we think we can take the next level of kind of applications and application delivery, where we're even closer to the code than NGINX core is. Yep.
NGINX Unit, I maybe you mentioned this and I missed it. Is NGINX Unit open source?
Yes.
Okay.
Yep.
Is there going to be a paid plus version of that, or is the plan more
Sure.
to monetize it through services?
TBD. So the typical development philosophy here is open source it for 2 years and let the community see what they're doing with it, observe how they're getting value from it, and then we'll kind of step back and think, should we monetize it? Is there a monetization strategy? One option would be similar to NGINX Plus. We could have some features in Unit that are not available in open source. The other thought would be maybe we unlock some things in controller. And so NGINX Unit will always be open source, but you pay for the ability to manage it in controller. So there's different paths. We don't know what the ultimate, but we'll kind of wait for, it went GA early last year, so we're a little over a year into what we think is a 2-year journey. Right now, 12% of all NGINX users, open source and plus, have already adopted Unit. So we're seeing very good uptake from our core user base on Unit as a application server.
What's the overall philosophy between open source, open core versus services. I know Chef just went all open source. I don't know if that's had any ripple effect in others' philosophies.
Yep. So I think, well, until recently, our philosophy has always been we want to continue to maintain a set of use cases that can and always should be open source. Using NGINX as a web server and a proxy will always be open source first. There's nothing that we're going to hold back from those use cases. And there are additional use cases where we think they're more enterprise driven, like load balancing and API gateway, where we would develop those features. So that's our overarching philosophy. I think we'll have to see how that continues as we continue to look at life with F5. I have no reason to suspect it would change. If anything, there may be an appetite to do more in open source because we don't have to worry about monetizing it, improving the viability of the business.
Is there any concern that NGINX unit will be adopted by AWS and turned into a product, much like ELB, or ALB, sorry?
Yeah, so sure, and that's the blessing and cursing of open source, but I think our philosophy has done things well. So ALB is a good kind of litmus test, right? So there's about 700 directives you can configure in NGINX. ALB exposes 40 of them, roughly. So we're sort of the graduate level course for them, right? If you were using them as a basic load balancer and you have more advanced needs, you would actually most likely go from ALB to NGINX, which is available in the marketplace, and they'll actually, their own architects will help customers in that direction. So for us, it's incumbent upon us that as we think about unit moving forward, we have to think about something similar. If someone's going to wrap and turn it into a commodity cloud-based service, we're going to have to find ways to stay ahead of the innovation curve so that there's more advanced use cases where you would know, okay, the cloud version's good for X, the commercial version that I can get from the marketplace is good for Y. As long as I think we can create a very clear distinction, it'll be fine. I think where some, and I'm not trying to speak on behalf of open source companies, but where a lot of companies find themselves in trouble is when the cloud version and the company provided version are more or less identical. There isn't a huge technical difference between the two, or at least a use case driven difference between the two.
Okay, thank you.
Okay. All right, so let me just touch on a few other things, right? So that's a little bit about the portfolio. What does it look like? So this is actually, we ripped this off a customer. This is their diagram. They don't have every single tool on this chart, but they have pretty darn close to all of them. And so what you're looking at is basically they had a traditional monolithic application. They were beginning to roll out new microservices application. That's kind of the top right and bottom right, if you will. The microservices application's all container-based, all Kubernetes orchestrated. And then they had this sort of complex tool chain that sat in front of that to actually deliver all the different capabilities. And they had one or two vendors. So kind of think of it as they use Occupy as their content delivery network. They had Imperva as a hosted WAF. It then went into AWS's NLB solution. It then went into an F5 virtual edition. It then went to an Apogee to authenticate API traffic. It then back to AWS as a network load balancer. And then it split itself off into the kind of traditional monolithic world and the new microservices world. The end state vision for this customer is to radically simplify that. So the first step is keep the content delivery network, which, by the way, you could roll your own. We have customers that deploy their own content delivery networks using NGINX as the underlying technology, but most likely you'll continue to get that as a service. Keep your network load balancer, whether it's AWS's, whether it's an F5, which is the most common thing we see in our customers, is you keep that. From then on, everything else can be done in our software. And so you would logically collapse those services down into that kind of lightweight distributed infrastructure. And what it basically looks like is two phases. And this, by the way, this is an idyllic end state. The customer's not doing this all at once. It's going to take them a couple years. First is I really want to kind of rethink that application gateway, the thing that sits above the network level technology, where I can do additional load balancing that's part of the application and DevOps tool chain. I can think about the API infrastructure. I can do additional proxying capabilities, right? So that is their step one. Think of it as a consolidated ingress-egress tier for all their application traffic. Now, it may be that every instance of NGINX doesn't do every one of these, but logically, it's one cluster of NGINX instances that does it all. And then, in the longer term, they want to do the back-end infrastructure as well. So this would be using unit as part of the vision I told you. So right now, NGINX Plus would sit as a proxy. So if you're familiar with service mesh, this is sort of what Envoy is to Istio, right? So we could be that sidecar proxy that sits in front of that microservice. NGINX is already the kind of the most deployed ingress controller for Kubernetes today. About 60%, 62-3% of all ingress controllers are NGINX. And so this is sort of their second wave, right? First, get all the north-south ingress-egress traffic. Step 2, kind of rethink the back end and optimize all the east-west traffic. And this is the very common pattern we see most customers undertaking as kind of the 2 steps. Some start on the back end and then make their way to the north-south. Some people start, most common pattern is to start with that application gateway at the front end, and then as they gain confidence and start moving to a more modern architecture, swap out the back end.
Do you see, is there any traction in getting Istio to support NGINX as a sidecar?
Sorry, is it?
Is there any traction in getting NGINX supported by Istio as a sidecar?
So we do have a project called Engine Mesh. It would allow you to operate NGINX in place of Istio. So it knows how to speak to Istio. Ultimately, and I'll get into this a little bit later, we've decided to stop corporate development of that. So we turn that over as a community project in favor of a different approach to service mesh, and I'll touch on that. But we do have users that use NGINX instead of Envoy and use Istio as the control plane to manage it. Okay, so in the interest of time, I'm just going to kind of talk about one last. So we talked about sort of the infrastructure patterns. There is one other way I just want to orient you to kind of how this ends up playing out. So we recently polled our customers and said, what percentage of your applications would you describe as monolithic, as pure microservices, or as some sort of hybrid in between? By the way, hybrid here does not mean hybrid cloud. It means a hybrid of monolithic and microservices, right? Which is basically I've peeled off a service or two and sort of bolted it onto that core monolithic application. And what we find is that 60% of most customers' applications are still monoliths. About 30% are in some sort of in-between state. And really only about 10% of their application footprint is net new, designed from day one in a microservices pattern. And the reason why this is important is because a lot of the new technologies that are coming out are designed for the 10%. Very few are designed for the 90%. Either modernizing a monolithic application or for the applications that are in between. Basically, if you're not using Kubernetes, you're SOL. That's how most, or if you're not up to Google spec in terms of how you develop your application, then you're SOL. And so we actually think there's an opportunity to help customers by thinking of it as the maturity curve. First, think about moving to software load balancing, kind of that application delivery controller that sits in front of your monolithic application. Then, as you begin to do more microservices, you're going to start seeing a lot of API traffic east-west across your data center as you start connecting services to services, services to apps. So now you're going to need an API management solution to manage all of that traffic. And then eventually, as you decompose this into a large number of microservices, usually measured in the hundreds, then you have the need for something like a service mesh that really provides a lot of the observability and tracing and capabilities you expect at a highly sophisticated system. The challenge is you have to get all of these from different folks, and if you're at different points in the maturity, you're going to have to rip and replace solutions as you go. So our vision is if you can get this from one platform, all managed from one control plane, then you can actually move applications along this journey as it makes sense, rather than having to invest in different architectures depending on what phase the application is. So kind of a bring the application to your architecture, not build an architecture for your application. And so that's kind of the technical kind of roadmap, if you will. You'll see demos of the next two, and we'll talk a little bit about service mesh. So I think I'm going to skip ahead a little bit. We've got a bunch of customer quotes, but I've touched on most of them. My favorite is, we're cleaning house when it comes to tool sprawl. We've got too many stickers on our Winnebago. That's kind of that previous customer's slide. That's their quote. They felt like everywhere they go, they just put another sticker from whatever state park they just came in, which is all the open source tools. To kind of sum it up, if I had to say anything, we're all about making modernization as easy as we possibly can. I think a lot of our customers aspire to a more modern architecture, but they weren't born 10 years ago. They weren't born in the cloud, and so they don't have a set of tooling that helps them get there. And we think there's an opportunity, especially when it comes to the networking and application delivery side, to provide that. What I want to leave a little bit of time for is, okay, great. How does this all change, if anything, with F5? And then I'll be done. So 2 more minutes. So on the surface, F5 is sort of as strong in its respective market category as we were in ours as an open source web server and proxy, right? So they're sort of the default leader in ADC. We were sort of the default leader in web serving and proxying and sort of making our way into the ADC space. And what we found is that the divide that I talked about with Capital One and AppNexus is actually a divide most companies find within their own companies. They have one team that's focusing on modern applications and then modern architecture associated with that. They have another team that's traditional. In fact, Gartner kind of goes out of their way to say you should actually operate this as mode 1 and mode 2. You should have completely different sort of tools and architectures. And I think what's happened is it's created that constraint where companies are struggling to then, when they get to a certain size and scale, reconcile these 2 different approaches, right? So I may be deploying Kubernetes and I'm looking at all the tooling and architecture for that, but I still have all my traditional data centers. When you think about the tooling needed for each of those approaches, I need a set of app and web servers for that modern world. I need to think about all the microservices networking, Kubernetes ingress controllers, service meshes. I have to worry about API management and a little bit of load balancing. On the other side, if I'm thinking about how do I scale all these applications, I'm investing in ADCs, I'm investing in infrastructure level security, application level security, DDoS mitigation, WAF, network firewalls. I'm thinking about DNS. And so sort of the net is, that's our vision for combining the 2 companies. We think there's a set of technologies, the green ones, that NGINX is best in class at, that's closer to the code, closer to the application. There's a set of technologies where F5 is best in class, sort of the red icons, that are closer to delivering an application from the doorstep to the customer. And we think we can bridge and create one platform that manages all of that. Right? In between is the concept of load balancing or an application delivery controller. But if you think about it, they were sort of hardware appliances, virtual appliances, and we're pure software. And so there's more of an opportunity to say, well, what form factor? If you need to run a lot of applications through it, you're going to want appliance. If you want to put it up close to the app or on a per tenant basis, then you want it further back and you want lightweight software. So really, our goal is to sort of offer choice within that one category, but otherwise outside of that, the 6 main components, 3 on each side, were complementary to each other. So it's really kind of our goal to span from code to customer all of those bumps in the wire that you saw that other customers struggling with, and try to rationalize that down so that customers don't have to worry about the sprawl, the complexity, and managing going from 13, 15 discrete platforms to deliver both modern and legacy applications. We think we can get that down to 1. So again, that's the technical vision. I can't go much deeper on what else we're working with until the acquisition closes, which is going to be by the end of this current fiscal quarter.